Well, welcome everyone, and thank you for attending our webinar this afternoon, which is entitled Digital Twins and Engineering Transformation. This is brought to you by the SAICE division of the Information Technology Division. Before we begin, I'd like to give you a very quick overview of the SAICE IT division. The focus of the division is to add value to educating our industry on new technologies, new developments, for example, Fourth Industrial Revolution, artificial intelligence, BIM, cloud collaboration, Internet of Things, both from a hardware, software, and human perspective, and to reimagine our workflows through 2023 and beyond. In line with our objectives, the division seeks to expose new technologies that may become useful to the civil engineering profession, particularly as the traditional boundaries between engineering disciplines are becoming increasingly fluid. We aim to serve our members by providing relevant content timelessly, always taking into account their needs. And we would like to attract more professionals into the industry, particularly by encouraging young and older professionals to become aware of new technologies, whilst always maintaining regard to their social, environmental, and economic impact. Just a few things about housekeeping. Please type any questions that you may have into the chat box, and we'll get to the questions at the end. EXA CPD points. CPD has been applied for this webinar, and when that comes through, then you'll be notified of your CPD points. So I'd now like to introduce our speaker for this afternoon. Christopher du Plessis is the Southern African Business Line Digital Lead at Royal Haskellingh DHV. He's currently the Digital Lead, where his role entails ownership of digital solutions and portfolios. He supports with digitization and digital transformation to increase business value and keep the company relevant. He drives the internal Digital Ways of Working program to strive towards a global uniform way of working and secure business continuity and domain knowledge. He was a project manager in the transport and planning business in the Netherlands. He was active in linking the infrastructure domain with the digital domain, creating propositions for automation, computer vision, techniques, and information management. He was also principal in the transport and planning business unit in South Africa and was an associate director in the Northern Advisory Group. One of Christopher's passions is to manage people and build a platform for each employee to achieve their best potential. So Christopher's areas of domain expertise are project management, managing the assessment process of multiple assets in the road environment, including bridges, geometric and drainage design in both rural and urban roads assets management, and rail design. So Christopher is also a member of the South African Institution of Civil Engineering, and he's registered with EXA. So with that brief introduction to Christopher. Christopher, I'd like to hand over to you so you can give us your presentation. Thank you.
Thanks, Peter. I could not open my video because I'm presenting, so I hope my sound is good. Everybody can hear me.
Yes, can hear you, Chris.
Okay, thanks. Thanks for the introduction, and we've got a lot to cover if it comes to what I want to present. And I think it's a hot topic, and it's something that we really need to have a look at as an industry. And as Peter said, where the technology part's coming in and our engineering transformation. So today we're gonna discuss basically some of the aspects framing the bigger picture. What is a digital twin? Building blocks. How to start, and some basic examples which we can have a look at. Let's just jump to the framing the bigger picture in terms of the engineering environment is we're doing quite a lot of construction of new infrastructure, which is good, and we need that. But if we start looking at the whole life cycle of an asset and you start having a look at what an asset is created for, is more on the operational side. And I think we as engineers are usually a little bit distant from the operational aspects because we come in engineer, we design certain things. But if you look at the whole process, the bigger part is in the operational phase. And I think that's where some of the values and the value in the new technologies comes in the operational phase specifically as well. And then, yeah, we talk about OPEX and CAPEX, but if you look at OPEX and CAPEX and the whole process, it's a process and the asset owner wants to benefit from it. Now, we're going to have a quick look on asset management and what it is. And I want to frame it in a picture that you have the view from the asset owner when we address digital twins and this transformation aspect.
Asset management is defined by ISO 55000 as the coordinated activity of an organization to realize value from assets. But what does that look like? At the simplest level, it means an organization is making the best decisions it can about its assets, based on a clear understanding of its long-term objectives and purpose. Asset management is the discipline that seeks to achieve this. Let's look at what it involves. Traditionally, asset decisions were bound to the life cycle of the asset in question, from its initial creation, through its working life, to its eventual disposal. These are not straightforward decisions. For example, how do you build cost-effective maintenance into the initial design? How do you measure the criticality of this asset to the rest of your portfolio? How can you be sure you even need the asset to begin with? Too often, we see these kinds of decisions being made in isolation from the rest of the business. With asset management, the plans that are made for each asset are always part of a bigger system, which is aligned to the organizational strategy. This alignment must reach down to the people doing the day-to-day work on the assets themselves, including outsourced contractors. Asset management decisions are always part of a learning cycle that constantly monitors and reviews performance based on past decisions and stays abreast of the evolving landscape of risks and opportunities that inform future decisions. So what do these decisions actually look like? Although there's variation between businesses and industries, typically they'll involve balancing the costs, the risks, and the performance of an asset or assets over a particular timescale. The discipline has amassed a huge array of tools and techniques that allow each factor to be understood, measured, and traded with the other factors, giving senior management a menu of options to choose from that they know have taken all relevant information into account. Decisions are only as good as the information they're based on, so an asset managing organization needs to treat its data as a core asset in its own right. There needs to be a simple process for agreeing what information is needed, capturing it, and storing it in one place, so that there's only one version of the truth. It's equally true that decisions are only as good as the people making them. This isn't just a matter of capability. At its heart, asset management is about collaborating across disciplines to make the best decisions using all the information and insights available. This is often as much a cultural challenge as a technical one. Organizations that have embraced this way of working have realized phenomenal benefits in terms of cost savings, risk reduction, improved performance, and so on. The IAM is at the forefront of helping organizations realize these benefits for themselves, giving investors and senior management the assurance they need that they really are maximizing value for themselves and their stakeholders. The IAM.
So, building from that video is in terms of what is a digital twin, and the key thing from the video, which I would like you to take from that video, is the information from the assets. Now, if we look at a digital twin and what a digital twin is, I'm going to show another video aspects which address it and on what it is and the purpose of it.
Climate change, urbanization, and emerging technologies are transforming both the public and private sector. In this environment, success, even survival, requires making the right decisions at exactly the right time. To do this, you need the most in-depth and timely insights. Insights gained from augmenting the physical world with the latest digital technologies. At the intersection of two worlds, we see the rise of the digital twin. A digital twin is a magic mirror that provides insight into a real-world asset, process, or system. It enables you to seamlessly connect the physical and the digital to gain visibility into how the physical world will behave under different conditions and support critical business decisions with accurate, timely data. Digital twins can enhance business processes, ensure people have consistent access to clean water, or even provide a safe flow of traffic in the world's most crowded cities. In the right hands, they can radically transform the way we think and operate, not just as organizations, but as a society, helping us to predict the future, identify the actions that lead to desired outcomes, and avoid costly, instinctive decisions. At Royal Haskoning DHV, we combine our engineering heritage and in-depth knowledge of the full asset lifecycle, business processes, and the environment with latest data science and predictive simulation capabilities. We help organizations to thrive, environments to reach their full potential, and the world we live in to become a better place. Your world is changing quickly. We can help you adapt faster.
So from that point of view, from digital twin and the complexity in which we tackle our role as engineers, and looking from a client's point, the asset owner, the digital twin concept and the term is becoming quite increasingly in a global relevance. And you can see basically from the Netherlands, say for example, putting it for having establish a party developing and driving this, and the same as UK digital twins and the sense of transforming infrastructure roadmap. So in a global aspect, that is becoming a term that is used, but it's a term, it's a concept. It's not always seen as a technology. So in terms of digital twin as a concept, and I think we need to define it very well, is there's nothing more than we as engineers know what we do. We gather information on the ground when we go and do a road, do a stormwater, do water. We capture data, we predict what the future is, we prescribe basically our designs, and then we change the physical world. So is that anything different than are we going to do anything different in our engineering? And that's where the whole step of digital twin comes in, and using technology, whereas we use data capturing different methodologies, IoT devices, your GIS platforms, all these data rich as databases or platforms that we can utilize information, and not using conventional ways, using drone technology, all these things to capture your data. So your methodology on capturing data will change. Then we'll put on a dashboard, which is your data is more structured. You can predict and simulate, and not always, as we say, design. And then using artificial intelligence, machine learning, you'll do pattern recognition and scenario planning, which will help you. Yes, we can use AR, VR to view the attributes, not the attribute data, geometric data, but there's also attribute data at the back. And then, of course, at the end, what a digital twin is, it is a push and pull machine-to-machine integration, alerts, notifications, things like that. So it's a normal engineering process which we follow, but we use technology. And that's a key thing from a digital twin, is we're building different systems with technology to advise us how we need to change our infrastructure, our processes and operations and assets, so that we can get the most out of it. So we need to understand that digital twin has got different levels. So if somebody asks you about a digital twin, you always need to find a little bit more detail. You can divide it into asset layer, process layer, and enterprise layer. And usually we talk a lot about the asset, and we build a digital twin in a geometric type of way, and we can have a look at it. But what about the information at the back? Where does it fit into the process? Where does it fit into the enterprise? And then, of course, at the maturity levels is we can have a look at what has happened, being a very low maturity, then informated, why did it happen? Then we can go, what will happen? And then what should we do? And then the machine to machine, correcting your system without actually doing something. It's automatically. Those are maturities in digital twin that will go. And it's always key to look at the life cycle of your infrastructure. So digital twins acted at 3 levels of the AEC value change. And if you look at digital twins can have a national, a sector or a national perspective and an agenda to integrate our systems. And you can see in the industry something like what SITA has put out, where they want to digitize or build a system around the water assets so that they can gather the information. That is a national, more national type of approach. But that is in essence a digital twin aspects which they're addressing. If you look organizational perspective is, then it looks over the whole designing and the whole life cycle of your asset. But you can also look at digital twins from investments in projects and also an operational aspect. So as you can see, the term digital twin can be used in different facets over everything, organizational, national, project, and assets. So at the back of a digital twin, how do we stitch these things together, if I can call it stitching it together, where we say engineering aspects, which we all do, the engineering assets, how do we take it further? So some concept of some building blocks that you can use it as is the as-built, your asset register, all those components broken up into components with information, if I can say it like that. As-built information, which then you go and you add your IoT, your weather data, your SCADA systems, which monitoring your equipment, your mechanical equipment, electrical equipment, or whichever equipment you add in. And then using that information to develop your operations and maintenance decision support, how you make your decisions on your assets, and build your advanced business logic, if you can say it like that, your data machine learning and data science aspects. And then you can start running scenarios. And once you start running scenarios, you need to know how to change your assets to get the most out of your assets. Again, you will see the biggest benefit in here is on the asset owner. But we as engineers, when we do CAPEX projects, we need to bring that in. And then, of course, advanced control, back and forward, how you need to change your assets. So that's in essence just what is a digital twin. And I hope that brings a little bit of clarity on the complexity and how you can use and what you can use a digital twin. But now, what do I do Monday when I get into the office? How do I build these things? So I'm going to give a little bit of a process and how the engineering is changing, it's transforming. And I'm going to throw a lot of concepts and a lot of details out. So I hope you guys catch it, if I can say it like that. So first of all, we need to understand digital transformation, digitalization, and digitization, where digital transformation is the aspect of leveraging emerging technologies to build new business systems, models, consumer, employer experiences. But we cannot get there if we do not do our digitalization processes. So improve business processes, leveraging digital technologies. And we can't get there if we don't do digitization, transforming our analog to our digital. And I think we all understand that printing a PDF or printing hard copy documents is not moving forward in capturing your data in a different way. Very simplistically put. So digitalization is where most of us as engineering, as a companies, as a government look at is we want to optimize our processes. So lower operational costs, yes. Greater productivity, workflows are simpler. So reduce our risk. So all these things are processes which you can digitalize if you've got digital information. It's quite a bit of a tongue twister. So basic frameworks of tackling these things. So the basic framework which I approach when addressing these things, you can't just use the digital twin or digital transformation as a language and say we're going to do it. You need to break it down into sizable, small, eatable, like how do you eat an elephant, happy for happy or piece by piece, and you need to break it down. So people, processes, technology is the three components you need to use. So if you use these three, you have better problem solving, but you need to equip your people for the future. You need to start integrating your working methods and embed technology behind it. Furthermore, you can go to town with these things and you can have more complex frameworks. You can see this framework at the bottom. It's got these three aspects in it, but it's quite complex. But that's making sure that you tick the boxes and your process works quite well. So let's quickly have a look at the people side. And the people side is the one that drives it. You can have processes, you can have technology, but people and culture kills all vision and strategy. If your people don't change and they do not take it forward, it does not help. So from a study, and you can have a look at it, Future Jobs, a report from the World Economic Forum for 2023, it was issued in May. And if you look at the H and the K, because that's the areas that we are actively involved, increased adoption of technologies and broadening digital access is quite high in what is seen in the industry as something that will change in 2023 to 2027. If we take it further and the impact of technology adoption according to this, you'll see that quite high, all the percentages, and you can see artificial intelligence, cloud computing, big data analysis, Internet of Things, digital platform. All these things are key things that will be adopted in industries, will be part of it, because that's where we're going. So to emphasize the aspects which is happening in a global scale, if you look at the UK, they've got a national digital twin program where they developed a skills competency framework where they stitch together business and digital skills, and they have a look at what do you require to actually achieve this, the national digital twin. And remembering what we did is, or what I said in the beginning, the digital twin is for that complex situations to help the asset owners or a national level. In this framework, they go into quite a bit of detail on business skills and digital skills required for this digital twin transformational approach. From data modeling, understanding it, security, data fundamentals, to your business, your transformation, leadership, collaboration, and how do you stitch these things together. And if you look at some of the profiles that they create is like a data leader, and it shows you basically what type of skill and at what level of that skill do you require. So a data leader at an organizational level needs to have a transformation leadership, quite high skill set and a data fundamentals. But lifecycle assurance, all those things, doesn't need it. And it's got a large amount of new roles. I don't think we as engineering and as government are approaching this in that level. If we say a data producer, that's where we come in as engineers specifically as well, is yes, we need to have some business skills and you need to have the fundamentals, data fundamentals. You need to understand how these things work. Also as an industry leader, and this is now where we need to see our industry leader in engineering having a know-how, and they address it on a national platform like SAICE, IT is basically one of those platforms where we can address these things. But these new roles needs to be seen or developed in South Africa. So just a myth, I've got a guy will not work. If we say in the engineering, I've got a guy that does IT, it's not going to work. Like we don't say, I've got an engineer if we want to do water or roads. We're very specific. And the same with these things as data engineering, data analyst, data science. And you can see each one of them has got a different area of expertise, but they can do a little bit of the others. And we as engineers need to understand this from a civil, electrical, we need to understand this and see how those can complement what we do and building those bridges. So how do we create our next generation? So preparing from a next generation, there's also research done on a conference paper. You can see it's quite old, to 2019, it's 4 years old, but still relevant. They did a survey of students and what is their familiarity. This is more in a first world country. So how familiar are you with mobile technology and big data and all those things? And you can see, yes, they've got some 50% knows about it and they're familiar with it. But then it comes to the engineering aspects. It looks a little bit worse here is, do they have the knowledge to use information management, GIS in software, construction management software? It looks a little bit more of a problem if we address it addressing that. And then if we look at the level of skills on the generic digital skills, I'm still talking databases, data analytics, and those things, you'll see there is some skill, but I don't think the skill is enough. And at an educational level, we need to drive this more. And you'll see in the universities of South Africa, data science being basically something that's integrated with engineering, and there's basically a department created. So those things are happening in South Africa, but we're still quite a distance off where we want to be. So my advice and my approach, how I would tackle these things on a staff approach, is always look at your staff in a personal goals, their knowledge, their technology, what they know, their learning path, and assessing. And then once you look at your individual, and you can see I'm using trees because it's a growth process, is you need to have your goals of your company, of the person in view, and see what is your digital transformation. Now, there's a nice body, Building Smart, which does professional certification and certain processes, which is very nice. You guys can have a look at it as well. So key question is, as I've mentioned, staff, people is the most critical thing in any success on any transformation, because culture, you need to change it. Are we approaching on a snackable, learnable interventions? Is it small enough so that they can digest and grow? Is it aligned to the person's personal ambitions, skills assessments, so that you make sure the skills are developed and enabling leadership? And that's on a people, how you approach people and how you can develop people. So that's it, that's people. Now we go to the second tier, which is process. Now this is quite a complex, and there's a lot of details in the process. But let's look at this slide. And remember, in the beginning of the presentation, we spoke about information, asset manager or asset owner. The data needs to be considered as an asset. Now, the key thing is the framework is the business process matures, and it increased the benefit to the business as soon as you start having the following in place. You have to have standards, and we've got national standards. We all got national standards. There's international standards. And as you break it down to each industry, your maturity and your standards that you build on your information sharing is increasing, your benefit will increase. But then you add the technology layer, and also how you process your information layer and your information to your systems, if I can say it like that, with structured data, unstructured data, things like that. So there's quite a bit of involvement in this. But the key thing is we build it on standards, and the more your information and the more data you can change into information, the better business value is it. So that's the concept on the process side. So let's have a look. Asset management, we know asset management is cost, perform, and risk, and it's a balance between them. You've got organizational targets of how you manage your asset and operational, and a lot is ISO 55 standards, which we use. That's the standard we use. We need to get it right on so many levels, and there's enough documentation, policies, and standards that we can use. But the key thing, which I don't see in the industry, there's a lot of talk about it, is the ISO 19650 standards. Now, if you read just part 1, it is the digitization of information. And if you remember from the previous slides, is to get our digitalization, our processes better and improve, we need to digitize our engineering information over the whole life cycle, because that will help with operational decision making and all those things. But from an ISO 19650 standards process, is the clients and government and asset owners needs to start saying what information is required, and then we as engineers will start producing it in our projects, the information, and we'll share the information back to the asset model at the end. And also the asset owners, what information do they need from the project creation? So as you can see, everything is stitched back at information, digitizing our information, and that will make our processes a little bit easier. So in short, in the sense of how do we tackle these things? So this slide shows you've got OPEX and CAPEX processes, but as you can see, you can stitch the ISO standards within. And as I said, as you need to build everything on standards, is the asset management and the information management. ISO 19650 is that digitizing of your information, and then your processes will become easier, which will tie then into our technology, which we'll address the next one. So embed it in your organization, make it policy, get a digital transformation process, scaling to the organization portfolio and continual improvement, because it's a process. We won't have everything right now, but you develop these things and you implement it. But as an industry, we need to drive it, and as government or asset owners, you need to start implementing these things. So how do I see what I've said now adding to our digital twin? The core aspects is the slide at the bottom. You'll see that is the process that I've shown on information management. Now, as soon as you digitize your information in a structured way, you can start building your roadmap for a digital twin, which will help you in your asset management. So you've got greenfields, brownfields methodology. We'll have a look at examples a little bit later, but then you'll go into your real-time data, your data analytics, data science, and as you can see, all these different technologies or fields will build your digital twin, and that will build your maturities. And we've touched base on these things a little bit earlier as well, is first we'll get a very low maturity now in our digital twin, saying just what happened. And then you'll grow it basically to intervention and what we should do. So that's in the process side. So now if we tackle the technology side, now I did not give a lot of attention to technology because I think we all know the technologies that's out there, and I don't think the focus should be on technology. I've seen too many companies, organizations, projects saying, okay, we can use this technology, or let's use LiDAR scanning, or let's use mobile mapping, or let's use blockchain or artificial intelligence. But does it make sense in the process on solving problems? Because we as engineers are problem solvers. Does it address the client's needs in terms of their asset management process, getting the most out of their assets? So yes, we can look at it as city, we can look at smart ports, we can look at smart, and everything these days are smart. smart roads, IoT devices, we use them. So all these things are out there and we know them, but you have to have the right team, the right processes to use the technology. You cannot have the technology and then build the others. It doesn't work. It is a bit of a problem. This is a slide from also 2018, I think. The future of construction from World Economic Forum is, and these are the 10 key things which they see will change the construction environment. And you will see there is prefabrication and modular construction, okay? But you'll see their cloud computing, you'll see their big data, you see their 3D printing, and you'll also see building information, number 10. All these things is changing the construction industry. We can see them, and certain areas got different maturity. First world countries are a little bit ahead on these things, but we'll see them in South Africa coming through more and more and more. So how do we start? It sounds complex, it sounds like a long process, but we can break it down and we can start small. So there's 4 ways to start. Basics is make sure you embed your processes, your standards into it. Approach digital twins as an integrated part of your digital transformation strategy. You have to get that in place. And then optimize in your operation. Optimization is looking at these things in operational aspects and always thinking about it. And then every investment and everything you as a company or a private sector, public sector address, have this concept in mind in building the future. You can go further into the process in addressing, develop your digital strategy, and then translating it into data solutions. And that's how you address certain smaller aspects, and then you build it together. At the end, you put all your solutions together to get to your digital twin. So again, I want to address this slide. If somebody asks you, we're doing digital twins, ask them at what level. Is it asset level, enterprise level? At what maturity is the digital twin? What are you addressing, and what problem are you solving in the life cycle of our infrastructure industry? Ask the right questions to hear what is the right answers to get the problems we're solving. So there will be a lot of challenges going forward in tackling these things. And I've experienced it firsthand in data quality and the access of data, and who's the ownership of the data, who's owning that data. And a lot of industries are tackling it, but they're not opening it up for use. We need to start getting to the culture on open standards and open data. Yes, talking to it, interoperability basically of your data, people and culture, which I've mentioned, is always critical. Security and privacy is becoming a large industry, in a large factor in our industry, because you have to have that in place. And then, as I've mentioned, do not focus on the tech, focus on the problem, and then use the tech. So you need to get that balance right. So I'm going to go into a little bit of examples in what I've seen, what I've been involved in. Of course, I don't know everything, but I can share what I've seen and what I've been part of. And hopefully this will inspire you to look at things a little bit differently. Maybe just from the examples, I'm going to just show a video and then I'll go into the examples.
Today, industrial assets are designed, built, and operated relying on numerous data sources and various models. Engineers work with enormous amounts of data. Specialized teams create models separately and conduct analyses for their specific tasks. The most current information and calculations may not be readily available for crucial decisions. This way of working in silos drives cost and inefficiencies, creates uncertainties, and represents a vast amount of time and resources. Is your company getting the most out of these investments? In order to give your engineers the competitive edge in a tough business environment, companies must look intensely at innovations that will drive efficiency. There is a better, more efficient way of working with models. DNV-GL's digital twin. The digital twin is a cloud-based virtual image of your asset, maintained throughout the life cycle and easily accessible at any time. One platform brings all the experts together, providing powerful analysis, insight, and diagnostics. Your engineers will work cost-effectively on a collaboration platform that gives early insight into potential conflicts, resulting in fewer errors and less rework. Sensor data, remote monitoring, and analytics made possible by the digital twin enable more profitable, safe, and sustainable operations. Based on broad and deep domain knowledge, DNV-GL is a world-leading provider of technical software. Through innovation, we are leading the transformation toward a data-smart future, ultimately improving your business results. And together, we can help ensure companies, industries, and societies become safer, smarter, greener.
So looking at that, it's just giving us a bit of perspective again of what we're talking about. But if you look at examples, we in the engineering aspect is we create a design and we quite involved in the designing aspect where we create a lot of geometric data. But if you go to construction, attribute data is created. And then if you look at operational aspect, there is a lot of attribute data and a certain level of information that is required, which is not required on the design phase. And you can see some of the models, which is always nice if we talk about digital twins, is the visual aspect, but you'll see that the attribute data is a higher priority at the end. So what we like to do is we say we do BIM, we use BIM, better information modeling. And in terms for design integration, it is critical, very nice to stitch together your workflows and your processes in your design. And that is automation in a lot of aspects, and it helps with clash detection. And those are things that develop. But what is the information at the back? Always think about it. How do you integrate these things? So this is a digital twin visually, geometrically of an asset. That's now new assets. If we start stitching things together in technology, like we said earlier, and we say we've got an existing asset, a brownfield type of things, we do scans, and there's a lot of different technology and dense technology in LiDAR scanning with very dense point clouds that we can use. But the processing and computing of those things becomes problematic. But that is increasing and becoming, our computers or the hardware is becoming better and better, which will help us build our models. As soon as you do your scans, you push it through to a model, which you build into a level of detail BIM model, which got information at the back, geometric information, and then you push it into design and your twinning aspect, visually and information, you know what you have. One of the problems which I've seen in South Africa is not knowing what you have, not knowing the assets. Hospitals, you don't have plans. The plans are missing because it's somewhere in a folder in some other office. But how do we put these things together and start scanning and having those basic existing brownfield project information together? Example of a digital twin where on an asset level. So if I look at an asset level, this is something that was done at the University of Cambridge, where they take a design of a breach and they start putting sensors in and linking those sensors to specific sections of your breach structure. And then you can see your dynamic stress and all those things, and you can see how your asset is performing. Is the value enough for the asset owner? Probably not if it's a new construction. But if you look at infrastructure that's 60, 70 years old, these things become quite important. Using technology to do inspections. We spoke about the first step on digital twinning is collecting our data. Doing visual condition assessments on a building like this, there's a lot of technology and artificial intelligence or image recognition on defects. In this use case, for example, 30 defects was modeled and a pipeline was built using the drone images to identify where these things are. And then you'll go a step further in putting a degree and a classification on your defect. And that information then filters into your process. The CEDA, as a roads director in Europe, which I was involved in a lot of different studies, and there's currently a lot of different studies in the digital asset manager or digital road manager, and you can have a look at this on their website, the Codec, Connected Data for Effective Collaboration, where they've used certain platforms and pushed the condition assessment and the design models to a model where you can manage your assets and see it, what is happening to it. And then they went further and they connected sensor data and how it's performing in operational aspect. Also GIS information, starting building BIM models and linking these things together. The city of Amsterdam has done proposals out and where they do risk-based and all their retaining walls next to their channels, looking at risk-based. What is the consequence of failure to the asset owner? And all of that information that's at the back is they're using INSAR data, which is a technology of satellite data for movement, which measures movement over time. And you can see if there's settling or movement. And then you use information of that asset and you start building these things together on a risk-based. What is the risk of this happening? What is the risk of that happening? And doing maintenance more on a risk-based. In the transportation arena, in-car data is one of the key information sources which is used. And it's a lot of projects has been put out by some of the national roads units. There is in terms of winter management, which is not that critical in South Africa, but asset management for your roads, skid resistance, how your car behave when it goes over an area which the skid resistance is not good. Looking at driver behavior over time in certain areas so that you can improve your safety of your road using that information. And it's all information from a car. The sensor on the wheel, the sensor on the steering wheel, and it's pushed to a cloud, and then it's used to assess your infrastructure. Some of the things that is driven quite hard and autonomous driving is the infrastructure ready for these type of cars, looking at hotspots of your infrastructure and looking at the safety of those things. Also different data sources, different way of engineering. More on the marine area is digital sand engine, which they call, using the concept of digital twin and your data capturing. Update your numeric model, your coastline positions over the next 40 years, and what do you need to do? That's what we've discussed on the digital twin process. But looking at that is what is in the past and what is the past, present, and future of that beach and the state of that coastline. So what will you need to do to invest money to make sure that these areas where the beach is changing, what will you need to do, or investment is required for those things? That's more one aspect. If we look at the Nationale Groeifonds in the Netherlands, and they've got a lot of, they put money aside to do this. And Talking Assets is a consortium of universities, research institutions, contractors, consultants, building these a consortium to build a digital twin in terms of the road assets, and they call it the National Asset Health Center program, where they build digital twins so that they can manage their assets better. And some of the deliverables in those things is from basically looking at a structure performance at an asset level into network control and scenario planning, which is on the right, using that information. Because in the Netherlands, your structures are quite old and it's steel structures and you're loading on your truck. So it's the end of life. But how can we extend that asset's life longer by managing the traffic on certain aspects, but real life monitoring and managing of your assets? Then, of course, the last one in terms of the ultimate is we love talking about smart cities. Now, what is a smart city then a digital twin in the terms of information? Everything is connected. Your connections in terms of your smart water, smart wastewater, smart roads, smart mobiles, smart everything is the connection of that information and building that models and using technology to achieve what we want to achieve in terms of the asset owner wants to achieve using this information and using this and opening up this data so that industry can develop models and solve the problems, the current problems we have with urbanization, the current problems we have with water, with traffic, with each area of engineering. We can utilize this information to solve the problems. So from a very high level now, we've addressed it now at smart cities, but if you start looking now at a national level, you've got the physical world, which is energy, water, mobility, materials, etc. You've got the digital applications, and then you've got the digital world, blockchain, big data, and it needs to overlay to each other. And what I've seen in some of the national at a national level, there's a digital council, and in South Africa there is things like that, and they address it basically on layers. But it needs to start from a municipality or a province level initiative, local initiatives, and then it needs to build up into the national council where we need to go with these things. And it's very, very important to get these things in place if we want to change and excel in our fourth industrial revolution transformation, if I can say it that way. So some of the initiatives created on living labs, and as I said, is because I've been in the Netherlands involved in these things, a lot of these things are Netherlands focused, but each city or entity is creating living labs where they're trialing and testing these things, and there's a lot of research being done, and each one of them are developing certain things. They've got a coalition for AI where all companies can be part of, and that's pushing the industry forward to utilizing these things. But at the end, there's a national vision of developing these things and bringing together the digital aspects with the engineering aspects. So that's in short what I wanted to say. I've said a lot, but the slide here just say transition to adaptive infrastructure. It is it's a, how can I say, a marketing thing, if I can call it that way. But CAPEX and OPEX we have a look at, but we have to integrate the SOPEX, meaning the social aspects to it. And that's all digital twin aspects which we need to address. So thank you.
Thank you, Chris. That was really excellent. I think the overview you gave was particularly good, and the emphasis on connecting people, process, technology. And also you sort of brought to the front as well that, you know, it affects all aspects of the civil engineering, if you like, the built environment. You gave examples there of rail, bridges, structures. You gave examples of transport, water, maritime, coastal. So it just sort of shows you that it's not sort of people often sort of associate the word BIM with buildings, but it's actually not to do with that at all.
That's right. As you say, Peter, and I think that is the misunderstanding. It's about the information. It's about the information, digitizing your information.
Yeah. I'll start having a look at some questions that have any come through. I'm just having a quick look in the chat. Debbie, I don't see any in there. I don't know if I'm not seeing them or if there aren't any, or maybe you can have a look as well, Debbie, and let me know.
Peter, I've had a look here, and Christopher, I don't see any questions.
Okay.
Delegates are welcome to write their questions in the chat if you'd like to ask Christopher any questions.
Okay, so while we're waiting for a few questions to come in, Chris, as you said, I think you used the analogy, how do you eat an elephant, bite by bite. Where, and I think you actually did sort of allude to this in one of your slides there. That you just start somewhere, but get a framework underneath that, and then you mentioned, using the ISO 55000 and the 19650 as well. Use that as a framework or as a base, and then just take something and then work with that, rather than possibly trying to address everything in one go.
Yeah.
What are your comments on that?
No, you can't address everything at once, but that's why if you look at a national level, we need to address it and start creating our policies and frameworks, our standards, which we work against. But at a company level or an individual level is saying, okay, fine, how do I standardize on my creating of information? So how do you create information more in a standard ways to know, because I want to use data science and program and all these things, so I need to structure my information. As an engineer, you need to understand that fundamentals of data. How do you manage your data? How do you going to share this information or this data to the next party? Start looking at those things, and standards is the key. And that's why I've alluded to or mentioned Building Smart, say, for instance. Building Smart is not a very big, doesn't play a big part in South Africa yet, but it is quite big, and it's all about information management. And there's a lot of groups that drives that as well. So it's a multi-layer aspect, national, provincial, private. Everybody needs to play their part.
Thanks, Chris. Okay, we've got a few questions or comments coming in through the chat. I'll just sort of take them step by step. One there from Chris. How far are we in South Africa on this journey? What's your guess on that?
So what I've seen in South Africa, I've had a lot of discussions with different clients, and I can tell you now in the government aspects, there's a lot of data that is not right. The structuring is not right. So not very far on that aspect as an asset owner in South Africa. If you look at the private sector, there's leaps and bounds that's growing. I can utilize, say, for instance, look at data centers. Data centers is quite advanced, and that's a very growing market. And they've got all these things in place, how they need to do it. But they in the CAPEX environment, so we'll need to see how it rolls out into the OPEX environment. There's little bits and pieces where maturity is quite high in information. Working in the Western Cape as well, they're quite rich in their data management processes and how they want to utilize it. But it's different maturities and different aspects. But at the end, we need that leadership, transformation leadership, to pull these things together so that we can build it together. National Department of Transport, Sunroll, they need to start sitting together so that we can push it down and implement it in our projects and make it a requirement of a deliverable at the end of the project, say, for instance. That's not just roads, say, for instance.
Okay, thanks, Chris. We have a question here from Andrew. Please let us know how your road and bridge folks are going with BIM maturity in RSA.
So I think I understand the question. So in terms of the company where I'm looking at, if you say I'm looking at my, they're doing very well in automation, their processes and all those things. But the key thing, if it comes to information management, because there's not a requirement from the client of what information is required on the whole life cycle of an asset, they're not very far in generating that information in the design phase. But if it comes to computational design, all those things, they're doing very, very well, in my opinion. And that's something that the industry needs to actually have a look at.
Okay, thanks, Chris. The next one up is from Fan. Thanks, what a presentation. On one of the slides, he says, I noted the acronym PDCA. Does it stand for Plan, Do, Check and Act?
I don't know which one it is, but it's most likely that.
Yeah.
I can't remember. Remember, the slides that I've used is a lot of different slides that I had to put together. So there might be some smaller aspects that might not relate 100% to the presentation, but it's to get the message out there.
Okay, thank you. Next one is from Peter. Where in SA is the construction industry compared to other industries in terms of level of digitization?
So overall studies, just to give it a global flavor first, is overall the construction industry is very slow in adapting these things because they do not see the value in that specifically. If it comes, then let's come back to South Africa. There's companies in South Africa, I won't know names, that has got a very strong digital transformation strategy, and they're implementing information management and all those type of things. And their complaint to me specifically was the engineers are behind. They are ready for these things. They are ready to, because their equipment is ready for it. But the engineers are not giving them the right information to do it. So we need to lead as engineering, civil or electrical, as designers needs to lead that, because construction industry are ready for it, but it needs to be given to them.
Okay, thanks, Chris. Next question we have from Madeline. Excellent presentation. Just wondering, how should a government department, e.g. a Department of Transport, adopt to be incorporating digital twins or undergo digital transformation? And how long do you think that could take?
How long is
a piece of string?
Yes, exactly. The thing is, if you look at government, say using Department of Transport, is they need to start getting it right in their policy levels. What do they want to achieve and how do they manage their assets? Now, if you look at the road asset management system that they've got, say for instance, they've got a lot of good technical, like the TRH18, the TRH22 for asset management, but it's not detailed enough. It's not showing how that information transferred to your management or your operational aspects. Network level, there's some information, but not on an asset level, very detailed. So it is there, and so it's not very, should not take long to get the policy in place. Let me rather say that. But policy means nothing if there's not accountability and there's dedication to implementing it. And then that's a national level. As a provincial or department level, they need to define that standards into what they want and what information they require for their operational or asset management processes. So how long? Depends on how fast we tackle it. So I don't know. It's a very difficult question. But it takes time.
Could you give insight maybe? Because you mentioned quite a lot of your time being spent in the Netherlands. Could you maybe sort of take from that and sort of say, well, they did this in such and such a time frame? Or
yeah, so I can tell you 2018, 2019 is basically when I was in the Netherlands. Is then, how can I say it? Everything was new. Let's just use artificial intelligence. Wasn't that using artificial intelligence and computer vision specifically of artificial intelligence, wasn't that used? 2 years later, we as a company started with a proposition or a product. 2 years later, the industry has passed us. and there was no market for us anymore. So now, but the key thing is smaller company has done it. So the industry is quite quick in terms of the first world country. You can see contractors jumping on that board. So in 3 years, what I've seen from 2019 to 2022, everything has changed. The way they do things, not in a mature way, but they doing these things. They physically on the ground and they utilizing the new technology. From a European roads aspect, the type of research papers are coming out frequently in addressing these aspects. So everybody is on board. They put money aside. Groeifonds has put money aside. So in 3, 4, 5 years, a lot can change. But if we start today, we have to take that first step from a national point of view and driving it. Then 4, 5 years from now, it can be a whole different process. It can be, the landscape can be totally different. Say 5 years, good turnaround time around, but not mature. I wouldn't say mature. I would say very good first steps in that direction.
Thanks, Chris. Another question here from Chris. Where does Sigfox or LoRa fit into this digitization journey?
I'm not sure. Sigfox and LoRa, I'm not sure. I'm not knowing those terms specifically. I won't know. I don't know if you can give more details of what that is and what industry or what specifically that is. I can give you details.
Okay, so Chris, if you want to just type in the chat lower down, we'll come to
So
it.
the brand is
Yes.
what is it specifically.
Yeah. Andrew, at Sunrail, we're under some pressure to avoid lagging by having our 1,000+ projects eventually gain BIM maturity. Hence my question. Not too sure.
Yeah, so I know from some discussions with Sunrail, some people, is there is quite a drive for the BIM, but at the end, as Sunrail needs to define what information they require on their 1,000+ projects at the end as an asset owner. Once you define that, you can push it all the way through from rehabilitation projects to design projects, and you can push what information you require. So that's something you need to sit around the table and discuss that. It's a workshop type of thing. You define it, you create it, and then you start giving your designers, this is the information I require.
Okay, thanks, Chris. Another question from Madeleine. What is the outlook for adoption in SA, or will the departments wait to get to a point where they cannot avoid it?
Yeah, what I've seen is the departments is not waiting. You can see, let's use Umgeni Water. They're putting out recruiting students for data science and all those type of things. If you look at some of great work eThekwini is doing in digitizing and monitoring these things, so they're not waiting. I don't think government or the departments are waiting. The thing is, they've got such a mass of things they have to fix, and they've got so many. They need more hands on deck. And I think that's where the private industry, our consultants, need to assist them. But we know procurement, we know all these things, we know South Africa's issues, but I don't think they're waiting. There is a lot of good signs. I've seen also, I'm just talking a little bit more KZN, Durban Innovate is what they've started, and that's using different technologies, opening it up. So they have done a lot of these things. But from a policy level and from an implementation mandating, it's like UK have mandated BIM. I can't remember what date now. They've mandated it, and the industry responded. You need that drastic intervention from government. Then we'll see the change.
Thanks, Chris. Shanae asked a question. How do you see this being useful in smaller rural municipalities in RSA, where electricity and connectivity are often unavailable? Will they be left behind, or how do we extend this to everyone?
So I know I've been asked that question quite a few times because rural internet connection is bad, but you also need to know that technology is changing. We know about Starlink, we know about satellite. So connectivity across South Africa and rural areas will pick up. So as soon as connectivity picks up, there's an educational aspect of people starting to get used to mobile phones. So yes, rural won't be left behind, but there will be late adopters on the curve. They won't be early adopters and all those things, but they will benefit, but much later. That's the only thing. But municipalities, all those things, can start getting these things in place. They can, because it's the same process. And they actually in a better situation, they can start getting it right, because when they actually get onto this, the information is ready, where the bigger department doesn't have it in place at the moment.
Okay, thanks for that answer, Chris. One now from Mrs. Tim. I have several other countries. I've seen several other countries have public sector mandated rules for BIM and digital twins. Is South Africa thinking along the same lines?
I wish I could tell you yes or no, but I don't think they are at the moment. I don't think, I have not heard a lot of the government talking about BIM specifically. They're talking about digital twin. Digital twin has been on their forehead, and I've seen a lot of requests for quotations, requests for tenders, naming and digital twin and using the technology. But if you don't get your information management structure, the ISO 19650 principles in place, you're going to fail, because you don't have structured data and you don't have your structure right. So that's all I can say about that.
Yeah, okay. And then Andrew has come back with a comment, just says we're at SANRAL, but it's a long-term digital culture change exercise. So really just a comment. Yeah.
Culture, as I mentioned, culture eats before breakfast.
And then Greg says this presentation has been information dense. Will it be available for review? Yeah, I can answer that. Yes, the recording will be on the SAICE IT division YouTube channel. So just give it a few days and then we'll get that loaded up.
If there's something specifically Greg's looking for, you can contact me as well and I'll share. I'm of the opinion the more I share, the better we grow. So
yeah, thank you for that, Chris. Another comment from Andrew, let's learn together. We made a start at SANRAL, okay. And then there's a comment here, TRH 18 and TRH 22 are not detailed enough. Where do we access the European papers related to road agencies? Please post some that would resonate with SANRAL if you can.
okay, I can do that. I can share that with them, not a problem.
Thanks, Chris. And then there's Dr. Alex who said communication technology somewhat similar to 2G used for many IoT devices. So I think he's referring to Sigfox and LoRa there. Okay. Yeah. And then one from Chris. There are cheaper alternatives to GSM for transmitting data from pump stations, etc. To digitize when we install IoT devices, that data needs transmission cheaply. So really just a comment there, you know, talking about the difficulties.
But it's great, Peter, it's great. I'm not a specialist in all the technology data, but this is where we need to say, okay, fine, there is ways, come up with the solutions, put it forward. We need to educate. I would love to see how that technology fits into a digital twin and how we can benefit from it. And that's a nice presentation to say, to educate us how we can implement it. So that's a very good, and we take note of it.
Okay, thanks, Chris. One from Andrew again. It says, thanks, Chris, for all the broader perspectives. Workshops are useful, but need to be hands-on too. Too many talk shops. So as we were saying, enough talking and let's start stepping on the first step to the journey. Yeah. And then Madeleine, do you know Alan Robinson, who's the chairman of Transport Division, is in charge of modelling at SANRAL Pretoria?
No, I don't know Alan Robertson. No.
Okay, he's at SAICE, so I can get with you, Chris, if you like.
Okay.
And then someone just said, okay, I contact him regularly. That was Andrew. Okay, so a few comments coming through now. Yeah, Madeline just said that was aimed at Andrew. Okay.
Okay.
All right. Thanks, Madeline. Right, I think if my scrolling, yeah, I think that's the end of the question. So it's probably time to wrap up. So thanks everyone for joining this afternoon, the SAICE IT division. We presented digital twins and engineering transformation. I'd like to thank Christopher for the excellent presentation that he's just given to us, and to acknowledge, the time and the effort that is spent in preparing these presentations. The SAICE IT division greatly appreciates this, as indeed I would expect all the participants have got some useful knowledge from it as well. I'd also like to thank Debbie for making the backroom arrangements, as it were, for organisation of this webinar. And then lastly, for the attendees this afternoon, if you'd like to join the SAICE IT division and a sister committee, please do contact us. You can contact us at SAICE, Debbie, who is our admin person there, and she will be happy then to connect with you. So with that, thank you very much indeed for attending today's webinar. Thank you again, Chris, and we'll meet you all again soon with some new topics. Thank you very much indeed. Bye-bye.
Thank you.
Chris, thanks so much. And